Okay. Hi, everybody. Welcome to today's interest session. Today's interest session is our introduction to blockchain technology. I'll give you a background to the presentation on kind of how it started and why we give it, and kind of give a work through slide by slide as we go through it. So just as a quick background, our interest sessions are given throughout each semester. From the ETIC, the Entrepreneurship Technology Innovation Center. I'm Dr. Nizik. I'm the director of that center. If you have not seen it, we have two centers. One is in room 107 of Harry Shearer Hall in the Old Westbury campus, and one is in room 607 of 1855 Broadway, the New York City campus. Through the ETIC, we run entrepreneurial programs. We have a NASA contract that we build prototypes with our student and employees. We have our own proprietary robotics program called Ursula that we've started from scratch, and all the technology around there is created in the lab to engage students at the college level and at the high school level. We also run our interest program, which is based on technologies that we identify as many jobs available, and but they're proprietary in nature, so that they're not necessarily covered in a classroom environment as much as they are given introductory sessions like this. And again, we have a YouTube channel that we have our leadership lecture series from IEEE on there. We also have a bunch of YouTube channels from our prior interest sessions on there as well. So feel free to subscribe and and kind of take a look at some of the videos we have on there as well. In addition to that, we also have our annual cybersecurity hackathon. We're a CAE, Center of Academic Excellence in Cyber Defense Education, designated by the NSA, and we run an annual hackathon with IAC Squared, and also our own hackathon as well each year. So those are given through the ETIC here at New York Tech. All right, so these are some of our, again, our YouTube handle and our ETIC webpage, and our Ursula robotics program as well, if you want to check some of those out. I'm just going to kind of cover today. Again, we have an abbreviated schedule today, so I apologize for that, but just talk about the presentation origins, where it came from, some recent blockchain events you would have seen over the past couple of years that have triggered a lot of discussions and talks and so forth. I cover database history, so we understand kind of where, as a database, that blockchain kind of came from, and what solutions it gives us that no other database really gives us. And then we talk about crypto versus blockchain versus NFTs, the differences. Some newcomers to the whole area may not really know the difference between those. And again, this is a high-level presentation for everybody, but we'll talk about a little bit about proof of work and proof of stake and the differences. And then we talk about some blockchain basics, and then kind of how it works and what does it solve. And also just some business and societal impacts. And then we also talk for those programmers at in a computer science program that are interested in coding. There are languages, specifically designed around creating smart contracts that we use: Solidity, Rust, JavaScript, Viper, and Yule are some of the languages that are available to students that are really into the coding end of things, that they can kind of have a career path. Again, interest is about career paths for our students, on things that they can do to carve out their place in the world. So some of the origins for me on this were years ago, several years ago. I was asked to present at a Hofstra event, believe it or not, and since then I've kind of really become enamored with some of the things that blockchain allows us to do. And also in a recent book I just had called Cybersecurity Workforce of Tomorrow that just came out in July, I have a few sections in there on blockchain and the applications it has on cybersecurity as well. So in giving this presentation years ago, I started out myself like, what's the big deal? And then I looked at the rapid expansion and acceptance of this technology from 2009 to 2023, like 2024 now. But I mean, it's just such a fast and unbelievable growth, and it's so new, even technology-wise, it's just so new still, in so many ways. And I was kind of taken by the abstract nature of it, where everyone would throw around a lot of terms, and I wasn't really sure myself about the differences. And then I kind of went through the process a lot of people go through, like, is it all hype? Is it just something that's kind of going to come and go? And then I, like everyone else, I kind of fell into this, like, oh, I kind of see this, I get it. It's different. and it's new, and it's and then I got to the wow, this is big, yeah, stage where a lot of us get to that are involved in it. And then I just said, how can I help everyone else kind of understand it, like go through the process that I went through? And that's kind of where some of these high level kind of discussions go through. And that's why I give this seminar every now and again in this environment, that we can just have a very kind of informal discussion about some of the basics of it. All right. So some of the things that you've seen and experienced, just like I have in the news and all that, we have these different things that we've kind of gone through. The FTX collapse, the big one. Tom Brady just had his roast on, and they were kind of making some jokes about that. Yeah, that we've seen these things, and there's a town called Murphy, North Carolina, where the entire town is inundated with a mining farm there, and there's noise pollution and people getting sick, and there's tax issues, and like this blockchain technology has created this ability to have these cryptocurrencies, which are require mining, to exist, which take a lot of energy and all that. And these mining farms, this process that we're going to talk about today. In this particular case, this Murphy, North Carolina, you should read about it. It's an entire town wound up getting kind of having all these issues because of it. So, and then there's Ethereum 2.0, which is a new release of the Ethereum platform, which allows something called proof of stake versus proof of work. Concept of crypto winter, which is really kind of past now. At the time, we're kind of getting back into into some stability now. And then we have something called stablecoin collapse, right? There was a different type of coin that was different type of cryptocurrency that we saw collapse. And then we saw this rise of NFTs, non-fungible tokens, that make digital content. They confirm its authenticity, so that it gives it value, right? So this, not even a cryptocurrency, but a picture or an image or a movie can be shown to be authentic digitally. So, so those are some of the things we've just kind of seen over the past couple of years and are driving this interest in this area. I always like to take this from a technology perspective. I'm not an economist. I say that right up front. I'm not even an investor in this, so I like to have my caveats out there. So that's not really what this is about. But from a technology perspective, it's really fascinating. And it's a database like everything else. They call it a public ledger, and this kind of shared public ledger that we have data in. But overall, if we think about it like a database, when we go back to from a historical perspective, we have flat file databases, we have SQL database, structured query language, then we move into something called relational database management systems, where we have objects that relate to each other. We have something called NoSQL. So when the SQL databases got too large to really interact with each other to do any kind of real data mining, we do data mining in it all the time. But overall, when the data sets get too large, even SQL fails. So we have this NoSQL, and then we had this limitation of being able to have machines process things on single machines. So we use multiprocessing, which is the Hadoop HDFS system, was one of these distributed file systems that we were able to distribute the work and come back and present this ultimate single solution off of distributed processes, right? So we have all these database solutions that are historically that are out there. We take these solutions, we put them in the cloud so we can operate on them. We don't have to host our own. We don't have to host our own databases, right? We can actually lease, right, with the cloud software like AWS and Azure Solutions. We can actually lease time on these servers, and we can host our solutions. And we don't have to actually own the equipment anymore. And so when we do that, we're able to host all these solutions in the cloud, which now takes away the ability to, or the responsibility of having this hardware. What none of these solutions really do is provide anybody with a guaranteed security solution that is essentially foolproof, right? Like, so there's no real way to, these are all perimeter-based security systems. Once somebody gets through the perimeter, they have access to your flat file, they have access to your SQL server, you have access to your distributed clusters, they have access to your cloud base. Like, from a security perspective, there's no real way to say that the data that you see on the database is immutable. It hasn't been changed. It couldn't have been changed. It's impossible to change. And that's the one thing that's missing from all of these solutions, is that from a database perspective, you can't really put it out there as a public ledger that people can see and touch and feel, but also that is guaranteed to not be changed. And that's actually what blockchain winds up kind of providing for us. So one thing that we see if it's the next slide here. So one thing that I do like to bring up is that we always talk about like crypto and Bitcoin and all that. It's not really blockchain. It's blockchain technology, right? It's blockchain technology, but cryptocurrency and NFTs, non-fungible tokens, they're all symptoms or applications or outcomes of blockchain technology. The blockchain technology is really what we're just talking about today and introducing people to, is kind of what it does, how it works, and why it becomes this kind of immutable, this naturally immutable kind of entity that people can look at and trust and say, yep, if I see it in the blockchain, if I see it in the public ledger, then the only way it could have gotten there is if it's legitimate. And the only way I look at it in the blockchain, when I see it there, I can guarantee that it hasn't been changed because of the design of the system. It's really that unique as far as the way blockchain works. Now, what blockchain technology allows to happen are things like Bitcoin and NFTs and so forth. But again, I just like to differentiate between the two. One is the technology and the platform on how it works, and then these things that come out of it, right? These cryptocurrencies, as an example, right, are some of the things we're seeing because of this technology. Keep in mind the blockchain is used in supply chain management and medical records and all kinds of stuff that is not cryptocurrency related, right? They're not just coin related technologies. One of the things that I'll just generally kind of put out there is that there's two types of things that happen. So one is that with this general ledger, I want to see if I can jump to a slide for a second here. So one is that with this general ledger concept, where you're taking a record, a transaction of some sort, right? To take crypto out of the discussion, if somebody said, I'm going to sell you my car, and the details of that transaction was stored in a public ledger, that public ledger is distributed amongst thousands of different hosts, right? And each one of those hosts is looking at all the other hosts essentially, and basically saying, look, this particular record is mirrored across all these different hosts. So to add something to the blockchain, you have to show something called proof of work. And proof of work is the solution of a mathematical problem that says, if you solve that problem before anybody else, you're allowed to add this transaction to the blockchain. Now, proof of stake works a little bit differently. I'm not going to go too much into that because I'm not going to say that I know all the details of this, but basically proof of stake removes the proof of work concept a little bit and says, if you have enough vested interest in that particular transaction or in that particular blockchain, then you will be able to add it to the list. But I don't really know enough about the differences on that side to talk about that. But there is proof of work and proof of stake, and proof of stake is really what Ethereum 2.0 is geared around. So the concept, just to make it, again, for our student population, as far as the generics of this, the history of this is all pretty new, right? So we have this initial paper in 1999 by Jacobson and Jules, but really the Nakamoto paper of 2008 is really what everyone kind of attributes this modern, design of blockchain technology, right? And the idea is if you take these transactions and you encrypt them with a secure hash algorithm with a 256-bit key, and you encrypt each of these components, and then you share it over a network, by the time somebody decrypts or tries to attack the network, these components of the chain all have different links forward and back between one node and another. And they essentially are able to know that something's been changed and correct it and repair it, which makes it immutable in nature. So the one slide I have up here is just to make you understand that this is something that has just skyrocketed, and as crypto has basically made it so unbelievably popular and powerful because of the financial abilities, financial nature of it. But as a technology, there's a lot of things that we're still kind of figuring out and learning and moving through that process. So just some of these, again, the slides may be a little bit dated from the last time I gave a seminar like this, but basically you'll see that there's a lot of different cryptocurrencies that are out there and able to be kind of bought and purchased and resold and everything else. But those currencies are based on blockchain technology. When you hear things like NFTs, the non-fungible tokens, the concept is how do you use blockchain technology to essentially make a digital asset hold value, right? So if you can say that I drew this picture and this picture is original and it's mine and it means something, but the original picture, the original email, the original note, the digital content that actually is considered valuable, but how do I know I have the real one? How do I know I have the original one? And that concept, that financial and that asset-based concept, is made possible through blockchain technology, right? So again, we're talking about the technology and how it worked, which we'll go into a little bit in the next slide or two. But basically, that concept of blockchain technology and how that works and how it secures the data, how it protects the data, and how it makes the data immutable, and how it's accepted by people, and that it is unchanged. How do we, by applying that technology to something like an NFT, a non-fungible token, a digital asset, it becomes valuable, right? This thing that wouldn't be normally valuable because who knows if it's real or not, actually becomes valuable because now it's part of this blockchain that made it real, right? I mean, you can see these are data. These go back 21. It's an old slide again from an old presentation. But some of these things, I couldn't even tell you what they were valued at today. Would be interesting to find out. But these are some of the things that actually wound up selling for as these NFTs became available. Yeah. So essentially, just for our students coming into this blockchain world, thinking about it from a database perspective. Essentially you are initiating a transaction between two people, right? Whether that's an exchange of Bitcoin as a cryptocurrency or another cryptocurrency, or whether it's an exchange of two people saying that I'm going to sell you my car, I'm going to sell you my house, I'm going to sell you without a middleman, right? Without somebody in the middle saying, let me do all the paperwork, let the bank have paperwork, let the insurance company have paperwork, let everybody, the town and the villages all have paperwork for this, to show that it's a real transaction. The concept is, how do we have that transaction just between two people, but how do we have the world accept that as a valid transaction? And the concept is if you can add this transaction to a public ledger that's readily available and readily, and people can see those transactions. And when you look at those transactions in a public ledger, you can say that those transactions are guaranteed to be the original transactions that were made between those two people. The only way we can do that is if there's a technology that exists that everyone accepts it, the way it works and the way it happens, is that somebody couldn't change that, right? And essentially, that transaction is added to a network. There is something called a proof of work, which happens that it's called mining. So somebody will basically mine that transaction and say that it's their job is to solve a complex mathematical problem. If they're the first to solve it, they're given permission to add that particular transaction to the public ledger. Once that becomes part of the public ledger, it's also encrypted with SHA-256 secure hash algorithm 256 bit encryption, which makes it unbelievably secure that way. But there's also, which one of the next slides, there's also a series of blocks that replicate the information in the block before it and the block after it. So this chain is not only publicly spread over thousands of computer hosts as part of the blockchain network, it also means that if somebody attacks one particular node or hundreds of nodes on that network, they would have to attack the entire network at the exact same time to crack that code and also make changes in the public network, which is really impossible. And that's why this entry into the blockchain, into the public ledger, once it does become entered, the way it spreads itself out and the way it protects itself and replicates itself over the nodes of the network, it becomes unbelievably secure, where the world kind of just accepts it and says, yeah, if it's in the blockchain, if it's on the public ledger, not only did it happen, because there's so much investment that has to go in with adding it to the blockchain, not only did it happen, but it's also, once it's there, it's really you can almost guarantee that it didn't get changed. And that's what makes the immutability of it so important. Now, later on in one of the slides, I'm going to talk just about some of the importance of the middlemen that are kind of at risk of disappearing if this goes into some sort of a commercially viable application where it's not just cryptocurrencies, if it's actually being used for, contracts, like things like lawyers and accountants and banks and town clerks and all these things that normally have to be involved to make a sale of a home, a car, so forth, legitimate. If all of a sudden blockchain becomes a technology where everyone trusts it because of the way it's designed, it eliminates some of the needs for some of these. And it becomes a very scary, world-changing type of technology where we don't have all those agents working for us at the same time. So just to put this into a little bit of a practical demonstration or example here, this is some of the code of an example of a snippet or a snapshot of code that's actually used to mine Bitcoin. This is a Bitcoin mining, like a small, but Bitcoin mining farm. Each of these GPUs is processing, the code to basically try to solve this mathematical problem to get permission to add the transaction to the public ledger. Some of the solutions that are out there that allow you to become a node on the network, that allow you to mine the coins that are available, that are waiting to be mined. You'll see all these different particular software solutions out there: Ethereum, multi-chain, OpenChain, Hyperledger. So again, for our students, our computer science students who are currently in Java or in Python or in C# or C++, depending on where you are working through your academic career, again, there's there's a hardware component to this. There's a coding component to this. There's a software solution component to this. There's an avenue that you have here to apply some of the things that you do in your regular courses, but this is blockchain specific. One of the things I like to bring some of the students up to speed on is that if you have if you have an understanding of encryption and cryptography, that's great. If you don't, it's kind of key to understanding the blockchain concept. So the first thing is that you have on a network, you're sending information from device to device, but you're sending it over telecommunications equipment and cables. You're sending it in binary, right? So the only way to really protect that data, they're sent in packets, and you can see these packets everywhere. So the only way to really protect that data is to encrypt it, meaning to scramble it so bad using some sort of an algorithm. In plain text, you use a cipher, certain algorithm to encrypt it with a key, and then you basically turn it into ciphertext, and that becomes what people see. So in a very basic Caesar shift cipher, if we shifted the alphabet, A becomes B and B becomes D and so forth. Then if you said hello world and it became E, F, G, and so forth, you wouldn't be able to read it unless you knew the algorithm, unless you knew the key to decrypt it. The key in this case would be a key of 3 to shift the alphabet three letters. So this concept of cryptography is key to blockchain because we're taking all the transactions and we are encrypting them in a manner that is unbelievably complicated, right? This SHA, the secure hash algorithm, it's a one-way hash, they call it. So once you encrypt something, it's impossible to reverse engineer it and decrypt it. And the 256-bit key makes it unbelievably complex to decrypt, right? So is it impossible with 100 years in a supercomputer? Probably not. But again, under this blockchain concept where you have multiple nodes spread out over the entire blockchain, each of those nodes looks at the node before it and after it and says, all right, this is what you have in it, and this is what I have in it. And then if I get damaged, you guys know what I have in there. Okay. So, and essentially the other thing I like to point out in these seminars is that we're still talking about data, right? So no matter what you're talking about, you're still talking about hash values and the block that it belongs in and so forth. But basically, we're talking about data, right? So the data is sitting on thousands of different individual computers that are all looking at each other in the blockchain. And when one of those computers is attacked, the others are, are still have all the same data. This replicated and mirrored public ledger is what makes it so powerful, right? So once those, so not only is it encrypted, it's also replicated. That's the point. One of the things that, from an attributes perspective, that you want to make sure you're aware of with blockchain is that the characteristics and the attributes of it are that it's decentralized, right? It's not stored like the SQL database on one server with a perimeter security, so that once somebody gets it, that's really it. It's synchronized, where all the nodes themselves are. Once a block is added, it's now replicated and synchronized throughout the chain. It's traceable. You can actually see who solved the mathematical problem, who added, which miner did that, who added it, when was it added, when was it replicated, right? You can trace it back if there is some sort of an issue. It's essentially immutable. You can't really change anything with the design of it. It is secure. It is scalable. You can have a lot of small with limited, be host for the public ledger. It is collaborative, it is auditable, and it is programmable, right? So you can write these smart contracts around it that you can use, blockchain networks to do different things, not just Bitcoin, not just crypto. You can use them to manage your individual, whatever you want to use blockchain for in your organization. So again, we talked about data before, as far as remembering that this is just data that's organized in a very unique fashion called blockchain, right? But essentially, each of these different blocks that are linked together in this public ledger across thousands of different individual computers, they have the transaction, but they also look at the previous and next block, right? So whatever the block itself is, right, it also has the previous block's information as part of it. So damaging one block of the chain on one computer, even if somebody tries to, it's not really going to do anything, because the collaborative nature of the network is that it's all kind of feeding each other to always replicate each other. So as soon as somebody attacks one, even if they try to address it or change the actual value of the encrypted data, the chain is so powerful because it's distributed and it's encrypted, and it's also a block, it's a chain in nature, and each block is designed to basically mirror the blocks on either side of it, right? So if you want to see this in action, this is a Russian bit mining farm, I believe. I forget roughly where I got the picture from, but I'm almost positive it's a Bitcoin mining farm in Russia. And again, you have these farms that are starting, that are running now. I mentioned that town in North Carolina. That entire farm using that much power and that much energy. The small town didn't generate any jobs because it was all automated. So nobody got a job out of it. It caused so much noise. It was a noise pollution issue where people started getting sick from the noise, actually. It drained their power so much and increased their power consumption so much that the town itself, the local residents, the cost of energy went up when they weren't even benefiting from the mining operation. So it had a lot of these globally and societally impactful issues that are going on that are just amazing, because it takes so much power to kind of win one of these contests to kind of solve this, as far as the proof of work goes, to solve this this math problem that allows you to add something to the blockchain. And they get rewarded, of course, if they do solve it first. They get rewarded in portions of Bitcoin and everything else. Right? And again, you see, A and B wish to do a transaction, right? They assign cryptographic keys. It's distributed on the network, right? Once it's validated by a miner, it's added to the chain. A new block is created, and then they create this permanent transaction, and then that's it. It's done. Now, again, we talk about crypto, we talk about NFTs, we talk about these value propositions and these items and these entities and these components, but it's like I said, it's being used in asset management. It's being used in supply chain management, right? It's being discussed in contracts, right? Contracts are being kind of created and signed using this, using these programming languages to create these smart contracts, right? The smart contracts are agreements that are between two entities of something, purchases and things like that. So we're seeing this kind of grow on a regular basis. And again, for our students, for our programmers, for our computer science students, this is Solidity. This is a tool for Ethereum. And basically, you know, this is a programming language, just like anything else that you can learn, that organizations that work in blockchain are going to be looking for people, probably looking for people now, that have coding experience, but can also apply it to creating smart contracts that are going to be applied in these different sectors. And again, they're just again, for our computer science students and these types of seminars, our interest sessions, just to understand that blockchain is a thing, it's out there. It's based on a technology that we're seeing these industries pop up, right? You know, cryptocurrency is one, NFT is one. We have smart contracts, meaning like contracts for other types of agreements, or is another one. So we're seeing these types of industries pop up, but it's because of the blockchain technology, right? That's what we're really talking about today. And for our students, for our engineering students and computer science students, there's a process for this. There's software solutions, there's interfaces, there's APIs, there's programming languages, right? So you're doing this in class now, but there is a path for you as part of our interest program. We always make sure that you understand that there's an actual commercial and career path for you, and it's not so different than some of the coding you might be doing today in Java or anything like that. So so one of the things I like to just make sure of, I use Bank of America a lot for this seminar. They're one of the largest acquisitions of blockchain intellectual property. So a lot of times when something in blockchain is created new or is invented, Bank of America will acquire the patents for that. They kind of admit themselves that they don't really have direct, all the time have direct reasons for buying. They just know that they don't want to be, if one thing or another becomes very popular or accepted, they don't want to be the one who doesn't own it. So and this is happening across the board, but Bank of America is, as you can read up on it, there's one of the things that they do is they focus on you know, on that issue. So blockchain overall, just to finish up here, again, I have the time constraint, but you know, it solves trust issues on transactions and contracts, that they're indisputable. It addresses and could address the high cost of transaction fees. If you have a lot of middle people involved, to prove that something is a valid contract, then makes it very expensive, the cost of doing the contract. It may have an effect on the need for service professionals in the future, right? If all of a sudden everything becomes blockchain and it's trusted, then, you know, some people might just go the direction of saying we don't really need all these other middle people to prove these transactions. And again, no cybersecurity risks. That's always a question in the future. You know, but again, overall, it is the most secure thing we've seen to date, and the no data loss or damage, meaning that even on efforts to attack, we haven't seen the damage be you know, unfixable or even long lasting. So, and again, business and societal impacts, we have no more questions about ownership or questions about validity or questions about no more service providers, no more transaction fees, no more fear of data loss or theft. In this utopia world, it sounds wonderful, and it could be something in the future. It could be the replacement for a lot of these things that we're, you know, that we're troubled with now. But again, right now, the core seems to be, you know, the concepts of the currencies and the NFTs and the smart contracts that are starting to slowly infiltrate and replace some of these existing contracts with a high overhead and a high cost. Okay. And with that, I thank you. I hope it opened your eyes a little bit to what blockchain was, how it was different than crypto, and where it lies in the bigger picture of things. And mostly for our students at New York Tech, I hope you saw maybe that there's a very technical and programming direction for you if you are interested in this type of thing. That there's a path for you, there's software for you to learn, and there's coding for you to learn, right? There's process in here to kind of bring you career-wise into that as well. Okay. And with that, I thank you. I'm going to stop the recording now, and I wish you all the best, and I appreciate you attending today. This will be on the YouTube channel probably next week. Thank you very much.